But thanks everyone for joining. This is, I guess, our session 2 of the 475 building blocks. And in this one, we're really prioritizing and talking through all of the air barrier transitions, or the main ones. For a lot of the project, just running a membrane will be nice and easy for your primary air barrier, but devil's in the details. And there will be points, mainly your foundation to wall, your floor transitions for your interior air barrier, and wall to roof. Those are the 3 main transitions that we'll be talking through today. There was the first building blocks was all about the window install. And that is, of course, a major air barrier transition. Your window is your airtight layer in that plane. So really just kind of jumping into it, we're starting off at the base, at the foundation to wall. And here you can see the Solitex Adhero 3000 membrane. This is our fully adhered membrane. So this is actually a peel and stick membrane. It's adhered to the plywood substrate behind it. And this project has a CMU block wall. So it was dying down and taped to that wall. And then it was treated with a vapor closed 3-part install of like this rubberized material that's used for below grade waterproofing. So you can see the rocks there. That's to allow that drainage down to a French drain. So this is kind of a standard exterior transition. This is mainly your waterproofing though, because where it's dying down isn't necessarily a continuous air barrier. But poured concrete has 2 main primary air barriers. The poured concrete itself, poured concrete is airtight. Block wall is not. The grout connection is not airtight. So we're oftentimes treating the grouts with a fluid applied material to make it airtight, but poured concrete is airtight. Or we have our subslab vapor barrier. And here we're showing the Stego Home 15 mil poly membrane that 475 provides. Plastic poly is vapor closed, acts as that capillary break, and is truly airtight. We do need to tape the seams though, and tape around any pipes or other penetrations that might occur. So here you can see the red tape, the Stego tape, that's being used to tape the seams of this green membrane, the subslab vapor barrier membrane. Here you can see the Campego tape used. This is the Proclima subslab vapor barrier tape. Both are really great options. And you can see that they ran that subslab vapor barrier up the perimeter a little bit. You can see this kind of floppy bit of membrane sticking out where it's meeting this concrete stem wall. This is to allow us to tape to the subslab vapor barrier down the line, treat it as a primary air barrier for our foundation. So we need to run it up and pass to allow that tape connection. A lot of times it's stopping too short and then it's just buried in the concrete. So here also the subslab vapor barrier in yellow now. I believe this was a brewery project where they kind of had this track system for maneuvering large materials. That's what you can see kind of gouged into the earth there. But we're just showing that's running long at that perimeter. On the right, you can see that the concrete was poured and still sticking out. And you can see they started to install the Intello Plus membrane on the underside of their roof system on that image on the right. So that's the interior air barrier and primary air barrier for the walls. So that will come down the wall and get a direct tape connection to that poly membrane, that vapor barrier. We're comfortable being vapor closed when we're touching or below grade. Soil is wet. The vapor drive is always coming inwards. But once we're above grade, we tend to want to be able to dry in both directions. Most of our climate zones now, the vapor drive changes direction based on the season. So we need to allow our assembly to dry through diffusion in either direction. And the Intello is actually vapor variable, so it really helps with that drying process. Here you can see again that subslab vapor barrier running long. This time, the mudsil, the bottom plate for the wood framing, is actually placed over that subslab vapor barrier. Now it can turn up the walls on the exterior side. This is a great approach. My concern is that membrane getting damaged when we're placing that mudsil wood framing over it, and that pinch point as it turns up. So we're oftentimes switching to the Extoseal Finoc tape from Proclima that 475 provides for that capillary break, that sill seal tape beneath the mudsil. But we can be running our vapor barrier along, and now we'll frame a wall on that mudsil that you see and then connect it to the exterior walls air barrier, whether that's the Mento 1000 membrane or the Adhero membrane, something like that. And here you can see they're taping the plywood seams with Tescon Vanna tape in the dark blue, but there's a little sliver of that poly membrane sticking up past. So you can see that circled in the red there. That's just that floppy bit of membrane. So that will get turned up to tape to that plywood sheathing. And then all of that will get covered with the Mento 1000 membrane or the Solitex Adhero membrane. That's actually the water resistant barrier, the waterproofing. So that joint will be completely covered and protected by the WRB. We're not worried about that reverse lap. In general, we do want to shiplap these connections to promote drainage, but in this case, we're not worried about that. The house wrap will all be outboard of this connection. People taping plywood, that's a pretty good home approach. Plywood can be decently airtight, but it's not manufactured to be airtight. So the thicker versions of plywood is like a decent air barrier. But for really high performance goals, we prefer to use materials that are manufactured to be airtight instead of ones that can be airtight but aren't necessarily guaranteed to be airtight. So here again, you can see this plywood seams being taped, and you can see that white tape on the image on the left that's sticking out. This is that Extoseal Finoc tape. So this is that capillary break tape. This is going over the top of the concrete before we place our mudsil. And this actually connects the interior to the exterior. So this is using the Contiga Solido IQ tape. This is the black fleecy tape here. That tape doesn't require any primer to adhere to masonry. So it's a really great connection point for this transition. And it's actually overlapping a little bit onto that Extoseal Finoc. And now we're actually transitioning our air barrier from the exterior to the interior. And that's mainly because in this case, they're leaving that concrete exposed. And so they don't want to treat it with vapor closed waterproofing that could be ugly, and then they would have to conceal that. So they're bringing the air barrier into the interior side of the assembly for their foundation air sealing. But poured concrete's airtight, so them even just taping to that concrete is a decent airtight connection. There's also a double-sided version of that Contiga Solido IQ called Contiga Solido IQD. And so here on the image of the left, you can see that they haven't quite pulled that release strip yet. So that what that white strip is the backing of that split release taping there, or that release strip on the exterior side of the tape. And so then the Mento 1000 membrane can overlap, and we pull that adhesive strip to get an airtight connection to that backside of the Mento 1000. On the image on the left, you can also see using Viscon to air seal the transition between the plywood and the rubble stone wall. That rubble stone's a really uneven substrate, so we prefer fluid applied over that uneven substrate. And now we can get into those grout connections and air seal properly. So it's nice whenever we're air sealing to something that's really uneven to use a fluid applied, such as the Viscon. For pier foundations or unconditioned crawl spaces, we're typically treating the underside of that floor system as our air barrier. We're insulating that floor. That is our thermal boundary for the foundation. And then we're running really a house wrap on the underside. So for which Solitex Mento membrane is appropriate, it's mainly probably going to be Mento 1000 if it's a batt insulation. If you're dense packing, it would be the Mento Plus. And in these images, you can see these floppy bits of membrane. This is the backside of the Mento 1000 that you're seeing that were placed over the structure. So that way it's running continuous between the pier support beams and that floor system. Now we can connect to those floppy bits. This will get filled with a batt insulation, and then this will fold up and connect to the Mento 1000 running continuously. And then the Adhero membrane that you're seeing on the wall here in blue, that will turn and get taped to that same Mento 1000. So for pier construction where it's well vented like this, you can be using the same water resistant barrier that you're using on the walls for the underside of that floor system. Here they switched to Mento 1000 just so they wouldn't have another layer of sheathing on the underside. But if this was a crawl space that was not well vented, or if there's really high humidity for whatever reason on the underside of that floor system, it's best to then switch to a lower vapor perm membrane, such as the Constavat Plus membrane. And that's just a low perm that is consistently low. It's not vapor variable. So if we have that consistently high relative humidity down there, we want to have a vapor retarder on the underside of that floor system, still airtight. Again, air is stopping most of that moisture transport. Air is really wet, is where most of our moisture is coming from. But that was just kind of a quick overview of our foundation to wall transition. We'll kind of check in at the very end if there are other questions, but are there any kind of urgent questions that popped up during that? Johnny, if you want to unmute, or Rachel, if you see anything in the comments.
We didn't see anything yet, but we're dropping links in the Zoom comments now.
Perfect. So now we're looking at floor transitions. This becomes really key when we have an interior air barrier, the Intello Plus membrane. So here you can see this kind of 3D model. We're referring to this Intello membrane, this white membrane, that stays on the interior side of your installation. But your floor framing is going to interrupt that connection. So how are we saying airtight from one side of the floor system to the other side? For your exterior air barrier, the Mento 1000 or the Adhero, that can just run continuous. The floor framing won't interrupt it. But for this interior air barrier with the Intello Plus, this is where sequencing becomes really key. So the easiest approach is to cover the top plate with a tape or a strip of Adhero. So it could be a wide version of Tescon Vanna, or some folks are cutting the Adhero membrane into strips. So here you can see that this is over the top plate of the wall framing. So this would be the first wall framing. This is covering over the top plate. They're using this OSB as their rim joist, and you can see their LVL floor system in the background there. And now they're actually taping on the exterior side from that Tescon Vanna up and over that rim joist. So this is looking at the exterior side. You can see that tape connection. They might want to tape the seams of that rim joist, but then they tape from that rim joist in to get an interior tape connection above. Another option is just setting a complete ledger. So you can run that Intello membrane continuous and have a ledger board as all inboard of that Intello Plus membrane, your primary air barrier. This really simplifies things, but again, is a major sequencing concern. Your framers need to know to place this membrane at this time. If they wait, it can then be hard to tape around all the existing framing that will probably be in the way and interrupt that connection. A retrofit where they're just placing a strip of the Intello Plus and then using the hangers, the metal hangers to support this floor system. This works really well, but I am worried about the IntelliPlus getting damaged during construction. So I prefer to switch to the Intello X membrane for this transition. It's like the commercial grade version of IntelliPlus. It's a little more robust, or you could use the Mento 1000. Again, it's just something that's nice, a robust membrane and also airtight. But this approach does work well. Another option is what we call wrapping the rim joist, where there's a piece of membrane from the inside going over the top plates around the rim joist and then back in. So you can see this blue membrane during this framing, or what this blue line of that floor system looks like. This approach works really well, but it gets quite complicated at the corners. Turning that corner and staying continuous and keeping that membrane where you want it below and above for that tape connection just becomes a bit too much origami, in my opinion. We do have the step-by-step install guide showing that origami, but this gets a little laborious and a little complicated. So just using a piece of tape that adheres to that substrate instead of being floppy that you need to fold just greatly simplifies things. Then it could also be multiple pieces of tape. One piece of tape over the top plate, one from that outer edge of the top plate to the rim joist, and then another one from that rim joist coming inwards to that subfloor system. So here you can see that it was over that top plate, and then they're taping from that top plate to that rim joist, and then they're turning that in and taping to the subfloor there. So that interior air barrier actually goes from the inside to the outside and back to the inside. It's complete and continuous, but there will be a little spot at that rim where it is moving to the exterior side of that floor system. That simplifies things. But from a building science standpoint, we prefer to keep that air barrier inboard of all the insulation. So on the right, you can see where they're just taping around all those floor joists. It's laborious, it's fairly easy, but you can go and tape around all of those. On the left, we're showing what if we forgot to tape in sequence when we're in framing. Well, now we can tape the Intello to that top plate and then use Viscon to spray where that top plate meets the rim joist, where the floor joists interrupt that rim joist or meet it, and then from that meeting the subfloor above. So that's a way where we can rely on the Viscon and come back and brush or use the Aerofix gun to spray those joints for that air barrier continuity. But again, on the left, we're showing you can just tape around that joist. It's a little laborious, but it's nothing difficult. You can see that they're taping around that joist, and then they're taping to the underside of the subfloor. And then above, the image on the right, they're taping the subfloor seams and then using the Contiga HF to adhere the Intello to the top side of that subfloor, or using a Tescon Vanna tape. I prefer Tescon Vanna tape over the Contiga HF purely because it's easy to play quality control with the Tescon Vanna. The Contiga HF, it's kind of a hidden connection. So with the tape, I can more easily visually inspect it. So I prefer tape connections instead of these adhesive beads, but both do work well. The shape of the joist could complicate things. So a TJI framing, a wooden eye joist, there's just a little more edges that you need to be pinching the tape into to ensure that you're adhering to that substrate and conforming to that substrate. But again, we're showing the Intello Plus just run directly up, tape around those beams, and tape to the underside of that subfloor system. So the Intello from above will just come down and tape directly to the top side of that same subfloor sheeting. Historic masonry project on the left. So this is a party wall that was treated with a fluid applied, and then they just taped where those joists were pocketed into that masonry to air seal that joint. On the right, you can see a metal I-beam. You can actually see some condensation from the thermal bridging of that metal. And you can see that it's a little bit more of a mess of tape for them to be getting and conforming around all those different edges and shapes. One other thing to highlight is on this image on the left, you can see the two of the floor beams are actually sistered. They're framed nice and tight to each other. So that's what we're showing right here. The concern is actually air moving between these sister joists. That could be an air leak. So what you can do for this type of retrofit is you can drill a hole between where those are meeting and then fill it with a Contiga HF adhesive or some other type of airtight adhesive. So now we're air sealing the point where those two are meeting at that wall. Devil's in the details for these high performance projects. So this is a lot simpler if we're holding our sisters back. So that way we're taping just around one beam where it's meeting that party wall for like an historic masonry project. But a lot of these old retrofits, you might have sister joists. So you want to do this drill and fill it with an airtight adhesive where it's meeting that air barrier. You don't want to bring it out into the interior part of the room because then airflow will just come upward of that. You want to do it right where it's meeting that air control layer. So this is that kind of like devil in the detail, making sure we're checking our existing sister joists. And when we're sistering new joists, we're holding those off of the air barrier so we can tape around that existing beam. Not a floor transition, but just an interior partition wall. Let's make sure that the framers have the membrane on site when they need it, so they can place this very simple floppy bit of membrane and butt their partition wall framing up to it. Now our air barrier runs continuous at the shell of the building. We only need to air seal the building envelope. We don't need to air seal all of our partition walls. So let's keep things simple. And this is just a proper sequencing to make sure that we're placing this floppy bit of membrane at the appropriate time. I.e., your framers will also be air barrier folks. They will be installing the air barrier. Here you can see we've done that strapping on the interior of the IntelliPlus, the what we call a service cavity, but also the IntelliPlus was run continuously before the interior top plates were run. So if this was the roof system, you can see that this Intello runs continuous and that these partition walls, the top plates do not interrupt that air barrier. And they can actually just fasten to that strapping. And now you have a little chase to run your electrical components instead of having to drill through or move them around that partition wall. So this is where that sequencing, making sure we're placing the interior air barrier during the framing stage for these critical transition points. Just another image of that where it's meeting the wall. We need to have that continue down the wall because it's the top plate would interrupt it for the ceiling, but where this is meeting the sidewall, it would interrupt it there as well. And this is just placing it in the meantime. You can see they just placed a little bit of seam tape at that seam that would be concealed, but they're not doing a lot of detail to tape it completely or make it look nice. They're just stapling up so it's out of the way in the meantime. So they'll probably fill those cavities with cellulose or mineral wool bats or on-face fiberglass bats, and then continue with the IntelliPlus air barrier on the interior side of that insulation. So yeah, we've kind of talked through the wall to the foundation and now how our interior air barrier transitions through our floor system. Give a little pause to check in with Johnny if there's any kind of questions that have come in up.
Yeah, we have a few that came in. Looking back at the foundation section, Justine asks, are there any of those membranes used in the crawl space resistant to curious rodents? What are your thoughts on?
Pest or rodent protection. I find the best thing is actually having an interior air barrier. So that's keeping your conditioned air in that conditioned space. For that floor system, it would be taping the top side of the subfloor sheathing. For your above grade walls, it would be the IntelliPlus membrane, also same for your roof. What that is really helping with is it's not letting your warm air move through that insulation where it could be further warming that exterior, where it could be condensing on the backside of that sheathing. So we want to, reduce the habitat that is so good for these rodents and pests and mice and whatever they might be. So part of that is kind of keeping the conditioned air in the conditioned space, and the other part is keeping things dry. So the Mento on the underside of that floor system is vapor permeable. It's allowing things to dry through diffusion, but that's a consistently high humidity area. We do want to use the lower perm material of Constavat Plus. There is no specific like pesticide or insecticide or anything in any of these membranes. It is really just rooted in we're keeping things dry and keeping our conditioned air in the conditioned space. There is no further pest or rodent prevention other than that.
Yeah, I've always heard it that way, that passive house buildings, for instance, are pest and rodent free because how do they know? They know through smells, they know through warmth, and those things are carried in the air.
Yeah.
And follow up, I see there. So what would we use on the inside of the floor assembly? We're taping the seams of our subfloor almost exclusively, right?
Yeah, I would say I'm most commonly seeing taping the top side of that subfloor, whether it's OSB or plywood. You can use the Tescon Vanna tape. The Advantech OSB subfloor that manufacturer, they are like pre-weatherized, which means there's a silicone finish on top. And sometimes you need to rough up that silicone to allow that tape connection. So I've seen folks just kind of hit that with an orbital sander or something, or a lot of projects, it adheres great, no concerns. But the only thing that adheres to silicone is silicone. If that is your only or that is your primary air barrier and you're going for passive house certification, it'd be best to use the Solitex Adhero 3000 membrane, or peel and stick membrane over that subfloor. The concern with taping the seams is that the OSB or plywood is not manufactured to be airtight. So it tends to be, if you're doing that and then also having a primary air barrier on the underside of the floor system, I think that's appropriate. But if you're going for passive house certification and you're only having an air barrier on the top side of that subfloor, then I'd recommend running a true airtight membrane, such as the Solitex Adhero 3000.
And next up, we have can a liquid applied air barrier work to seal the joist space around the joists at the rim board, etc.?
Yeah, it can. So that's what I think is a really great option for the Aerofix gun. So where you can see in this image on the left here, that's what the black is. They sprayed with the Aerofix or the Viscon to be hitting those joints. So that's a great approach. It's a higher material cost than using the tape, but a lot quicker of an install. So you're kind of choosing a higher material that's a quicker install than a lower cost material that's more laborious, which is what we would be showing on the image to the right there, where we're taping around each floor beam. So totally fine to use Viscon to be spraying those connection points between the rim joist and the floor joist meeting it. You would also be spraying where that rim joist is meeting the top plate, which your IntelliPlus should be taped to. This image on the left is missing that piece of tape connecting that Intello to the top plate. And then you would also be spraying where that rim joist is meeting the underside of that subfloor sheathing. So that's a really great approach. I would spray wood framing, things that are dimension, that are very stable. I tend to prefer to use a tape if it's a two membrane connection, because the membrane kind of has this flex if someone were to push on it. I'd be worried about that viscon uplifting off of the framing. But you can push on that wood and it's not going to move. The expansion and contraction of the wood based on the season is not an issue. The viscon can elongate and stay airtight with that wood movement.
So following up to that, in the situation, the viscon, the Aerofix, is that relying on the rim board as your air barrier at that point?
It is.
Yeah.
So, you could see where they're not hosing all of it down. They're leaving a little bit of exposed wood here. You could spray it all with viscon. That'd be great. If you're seeing the like knots in the wood or a biscuit in the plywood or something like that, I might hit that with viscon. Again, all of this is like lumber isn't manufactured to be airtight. So you might get some minor air leaks through the lumber itself.
And then next up, this one I think we have a whole presentation on, so we'll have to do the abbreviated answer. But what does the Intello do if the adhero on the exterior, if you have adhero on the exterior and enough exterior insulation to prevent sheathing condensation? Is adhero enough of an air barrier?
Um, so yeah, we have whole other blog posts and presentations on this. There are two schools of thought. One is have enough exterior insulation to warm your sheathing above 48 degrees Fahrenheit year round. That approach works really well if it's vapor permeable insulation. If you're using exterior wood fiber board or mineral wool board, then you can still dry through diffusion. So if you're having that thick layer of exterior insulation, then you don't necessarily need the Intello Plus membrane. It would only be helpful, but it might not be as necessary. The helpfulness then comes much more of maybe you have some thermal bridging at top plates or bottom plates or other transition points, or maybe you don't want the off-gassing of the wood framing materials or the adhesives used in the OSB or plywood, things like that. So it'll further reduce the risk, but might not be necessary if you have enough exterior insulation outboard of that sheathing to keep the interior side above 48 degrees Fahrenheit year round. The other kind of school of thought is no exterior insulation and have the Intello as your interior air barrier. Now we can use double stud construction or things like that and have a big thick layer of fibrous insulation. And now we're keeping our warm air within that conditioned space and not letting it move through that insulation where it would condense on the backside of that sheathing. And that sheathing is going to get cold. That's totally fine. So kind of two schools of thought. But yeah, if you have enough exterior insulation and that exterior insulation is vapor permeable, then you don't necessarily need the Intello. Might be more key for your roof. If it is a vapor closed exterior insulation, I would still rely on the Intello or utilize the Intello because you're not drying through diffusion towards the exterior. So now that vapor variability of the Intello becomes very key. So that way you're not moisture loading the assembly during the winter. But yeah, check out an interior air barrier does it better on our blog posts. And we have quite a few posts around the vapor variability of Intello.
And last one, and then we'll get moving on to the next section. How are the fasteners for the ceiling strapping air sealed at the Intello? And I think this is referencing that one that showed the service cavity.
Yeah, so it's totally fine to fasten through the Intello as long as you're hitting the framing on the other side. It's installed with staples. So when that staple hits the Intello and goes through and bears into the framing behind, it will pinch that membrane to stay airtight. So that is not a concern from an airtightness standpoint. We do want to orient the staple so that way if there's billowing on the Intello Plus membrane, it's not pushing out and creating a little air leak at that location. see our PDF install guide or a video install guides for that staple orientation. But totally fine to staple through it, screw through it, as long as you're hitting the structure on the other side. And this is all about air sealing. It's the same thing for the exterior, but on the exterior, we want to make sure we're allowing drainage at that plane, because when that staple is pinching, it's staying airtight, but if water sits on that fastener, it could work its way in. So the Menta 1000 doesn't self-seal like the Adhero does. The Adhero is that peel and stick, that fully adhered version. And that one the adhesive will seal around that fastener penetration. So it's airtight and watertight. So kind of separating out the airtightness concern versus a waterproofing concern. But great. I'm going to move on to wall to roof transitions. We'll also have time for some more questions at the end. Monopoly framing has become very popular. That is where you have a direct connection from your wall to roof sheathing, and there aren't continuous rafter tails that are extending out through that sheathing to create the eave. It's called Monopoly framing because it looks like the little Monopoly house in the board game. And so this really eases that wall to roof transition. And what's really great about the 475 exterior membranes is all of them utilize this monolithic film within it. And that film is incredibly airtight and incredibly watertight. A lot of other options on the market are a microporous membrane where there's kind of like little holes in that membrane. And there's a reason why they recommend a different option for the roof application than the wall application. Because with that microporous system, they're not all that airtight or watertight. While the stuff from 475 utilizes a different technology that's incredibly airtight, incredibly watertight, and also vapor permeable. But this means you can use the same membrane on the wall and the roof. And we just want to shiplap that seam to promote drainage. So on the left here, you can see the Menta 1000 membrane. It's being installed over plywood that has their seams taped. And on the right, we're showing the Solitex Adhero membrane, the peel and stick membrane, the fully adhered version. So with this monopoly framing, we still want to create an overhang. We still want eaves. We want to shed the water away from the building. It's why we went into caves to begin with. It's the main reason we built homes. But there's this approach called applied rafter tails, where we have the monopoly framing, and then we're custom cutting these notched boards that are cantilevered. They're mechanically fastened down into the top side of the structure, and then they stick out to create a substrate to hold our roof material as it extends past that wall to create that eave. And now the depth of this framing is starting to create our above sheathing vented location. So this is creating a drainage plane and a vented location that will be below our finished roof material. So this project might be covered with metal or slate, something like that. But most oftentimes we're actually seeing an additional layer of sheathing to hold asphalt shingles. And now we're venting below that layer of sheathing to meet prescriptive code, giving that continuous substrate for our asphalt shingles. The membrane above that additional layer of sheathing doesn't really matter. It's fine for that to be vapor closed because we're properly venting all below it. It's normally, I think code is saying that this vented cavity should be, I think, an inch in depth at least. Maybe it's 1.5 inches. But I see most projects trying to make that about 2 inches. The lower the slope, the greater that cavity needs to be. So I'm normally seeing that 2-inch gap starting at about 3/12 pitch or greater. Below a 3/12 pitch, it's getting debatable if there's enough of a pressure differential from the eave to the ridge to adequately vent. So to make up for that pressure differential, people are making that drainage gap or that vented cavity very deep. which just takes up more space and uses more wood, but is otherwise a great approach. Here we're showing where maybe those applied rafter tails weren't applied to the roof, but instead is a ledger board. So you can see that there's a ledger board applied to the rain screen battlements. They could then use, Simpson hardware to attach that eave overhang. And what I like about this approach is that ledger is attached outboard of that rain screen. So now we're allowing direct drainage from the wall to roof and keeping it within our drainage plane. If this ledger was directly against the house wrap, now we're interrupting that vented cavity on the wall, but also then we would need to flash that or somehow protect the top edge of that ledger framing. But by applying it to the exterior side of our rain screen strapping, we're allowing drainage and venting at this location. So kind of slick approach. Maybe they forgot to apply those rafter tails, or they thought this is an easier approach. I'm typically seeing this with Simpson hardware to support those eaves and overhangs. Or you can tape around all of that. So now these are continuous rafter tails. This wasn't monopoly framed, and now they have to tape around all of those continuous rafters. Energy moves much more freely with the grain of wood opposed to across the grain. So those continuous rafters are a thermal bridge concern. It is nice if they could fill and insulate that soffit space to help reduce that thermal bridge. It is also, an air barrier concern. So now they are having to tape around all of these. Here we're showing where they're taping around that continuous rafter, but they're still creating that vented plane above the vapor permeable roofing underlayment. So here you can see they're still allowing drainage and venting in this location. This is above a structural sheathing, but they have an additional layer sheathing to hold their roof finish. So from a prescriptive code standpoint, they are venting below this top layer of sheathing and allowing drainage and venting at the eaves. And then they would hold that sheathing off a little bit at the ridge to allow venting at the ridge cap there. A lot of projects are transitioning to an interior air barrier for the roof, if it's an unconditioned attic, or if they're venting below the sheathing that is touching the framing, the rafters or the truss system. So floppy bits of membrane can be placed. So here you can see this green airtight membrane, and that it's lapping to the exterior and coming inwards. So it will be taped to the Intella Plus running on the interior side of this truss system. And we're talking about this transition coming from your wall's exterior air barrier over this top plate to the Intella Plus on the interior side. So that would be when we're venting below this roof sheathing. Oftentimes this is a roof truss framing, and maybe not site cut rafters. But we want to allow this vented cavity at that eave or that soffit connection here. But we need to keep our air barrier complete and continuous. So we cannot connect to an exterior air barrier because we're venting in that location. So we need to transition to an interior air barrier for our roof system. So this would be the Intella Plus membrane running on the underside of that insulation, typically in the ceiling plane of the top floor there. And again, we're just topping this top plate with a wide piece of Tescon Vanna so we can terminate our house wrap, our exterior air barrier on the wall to that same material as our interior air barrier on that ceiling plane or floor of the unconditioned attic, however we want to talk about that. But this attic is then vented at the eaves and oftentimes typically at the gables as well. A lot of more humid climates, they're trying to avoid this because this is letting in a lot of outside air into our insulation. And that outside air and climate zones 3 and below tends to be quite humid. So a lot of projects are keeping with that cathedral ceiling setup for more humid climates, and they're maybe doing a vapor diffusion port at the ridge, where they're using a vapor closed material over the sheathing, but then at the very ridge peak, they're switching to the Solitex Mento 3000 membrane, which is a very high permeability membrane, perma 38 perms. So any moisture that's built up in that insulation and framing can diffuse out at the ridge. So that's becoming a more common approach for climate zones 3 and below. But I'm seeing this for all types of climate zones. This becomes very difficult for retrofits. For retrofits, it can be quite difficult to access the top of this top plate to get this air barrier transition from the exterior side of the wall to the interior side of the roof. Kind of getting into those knee walls or whatever is going on there can be problematic. So here we're showing just the wall framing, and the top plate is topped with a wide piece of Tescon Bama. Again, using the tape means it can adhere to that substrate and really eases these corners. If it was a floppy bit of membrane, that does work well, but then the corners get some complicated origami. And here we're showing the Intello Plus membrane. This is all inboard of our insulation for the roof. You can kind of see where the Intello dropped down to connect to the subfloor here. This knee wall behind there, they're packing with a lot of cellulose. You can see where they patched the holes where they were dense packing behind this Intello Plus membrane. And they had the strapping to create that service cavity, this interior chase for their outlets. For a lot of these truss systems, we don't typically need as much R value that would take to completely fill the truss. So there's oftentimes some additional framing worked in between the trusses to establish a plane to install the Intello Plus against, so then we can still insulate and fill that cavity completely from the interior side of the Intello to the back side of the sheathing. Or if it's a vented cavity, it tends to be the backside of those foam baffles that a lot of folks are using. If you're using those foam baffles on the underside of that sheathing, it tends to be for this type of roof system where they're applying the foam baffles to the underside of the sheathing. It is pretty important for those baffles to be shiplapped to allow drainage. And then I'm oftentimes seeing a tape or caulk joint where it's meeting the framing and at the connection points. And this is trying to make them as wind tight as possible, just trying to prevent that wind, that air moving over and wind washing this insulation, which can greatly reduce the R value. So trying to allow drainage in that cavity and vent, but still kind of create a wind tight layer between that vented cavity and the insulation itself. We always want a blower door test. That's the best way to play quality control. Blower door is a shroud that you put a fan into. That's what the red material is. You set that up to an exterior window or door, and then that fan pressurizes or depressurizes the building envelope, so you can measure literally how airtight the project is on the job site. And we can use that to track and find air leaks and make the project even more airtight. So I recommend doing blower door testing early and often. Ideally after your air barrier is installed, but you still have access to it. And then typically again, after your windows and doors are installed, ideally again, after your subcontractors have come through and run their plumbing and electrical, which might be some unaccounted for air barrier penetrations. And then finally, after the drywall. If you're only doing it after the drywall is installed, you've now concealed that air barrier and you're limiting the access to mend, patch, and fix it. But check out the 475 website for more. This is all part of our Tricky Transitions blog series. So there's now a blog post out just on the wall to foundation, floor transitions, and wall to roof. but I have some time to stick around and answer any other questions. All of these details are also shown in our 475 Smart Enclosure ebooks, which are free to download through our website, and they come in PDFs or DWG files. Thanks for taking the time. And Johnny, what questions have been coming in as I'm
Yeah,
chatting through?
and thanks for your questions, everyone. This first one comes from Scott asking where would the installation be in this assembly, and I believe this was during the time that you were showing uh the rafter I think it was here that it was asked, but correct us if we're wrong about that, Scott. Where would the installation be in this assembly?
Yeah, the insulation is inboard of the membrane. So it'd be behind this membrane. I would say this is most likely a cathedral ceiling. So the insulation is following the shape of the roof. And yeah, so all of this, the membrane is concealing the sheathing, which also then has insulation behind it, or maybe there's a rigid board behind this, but I would say typically that house wrap is against the sheathing and exterior insulation is outboard of the house wrap. So I think this is probably dense packed cellulose or mineral wool bad or unfaced fiberglass bad on the other side of this for all these assemblies here. I have seen this type of applied roof assembly done with exterior mineral wool. That does work well. Mineral wool allows drainage in the boards, so they could be topping this with exterior fibrous insulation such as mineral wool.
So would you say that it could basically go on either side, sort of, depending on, yeah, in the monopoly frame situation?
Yeah, it could be on either side, but if it's on the exterior, I would want to ensure that it's vapor permeable. The big idea of these vapor permeable membranes is that we're letting the assembly dry through diffusion, and then that moisture dries into this drainage plane, turns to condensation, and sheds away. So if you top that with something vapor closed, you can be trapping moisture against this house wrap or against this roofing underlayment. And then the concern is that it's not effectively draining and it's following a fastener back into the assembly. So we want to prevent any of that pooling or trapped water that might occur by covering it in a vapor closed insulation such as rigid foam.
And on that note, right after you had covered the interior penetrations for the service cavity on the inside, Jeffrey asked, or I've seen butyl tape on the inside of furring strips to avoid a penetration. Is it unnecessary over Mento? So I guess maybe covering inside and outside, using butyl tape where these battens are.
Yeah, so on the exterior, I would place the butyl tape between the strap and the mento for the roof, but not on the walls. And that butyl tape would be the Tescon Nidec, which is a double-sided tape that is used between the strap on the roof and the mento membrane on the roof. The adhero membrane has the adhesive throughout, and that will self-seal around that fastener penetration, even for roofs. For walls, we're allowing drainage, so we shouldn't have any standing water that could work its way in at a fastener. But these pitched roofs, maybe there's snow buildup or something like that that could have standing water for a little bit, even on a 312 pitch or greater. So it's nice to have this Tescon Nidec tape used between this roof strap and the Mento 1000, Mento 3000, or Mento Plus membrane.
And then I think you addressed this, but about the wind washing, sounds like you saw that question come up when we're showing the 2 layers of insulation um, on this one.
Yeah, so a lot of projects are installing these foam baffles on the underside of the sheathing, and they would be kind of installed in between the truss system here on the underside of that sheathing. My concern with the foam baffles is I rarely see them installed properly. They tend to butt up to each other and not shiplap. We do want to allow drainage in that plane, so it needs to shiplap. And we want to prevent air transported wetting, i.e., the outside air getting in and around those baffles into our insulation and framing. And we also want to prevent what's called wind washing or thermal bypass, where we can have that outside air move into that insulation and create convective loops that can greatly reduce our R value. Insulation is just trapped air, but that trapped air needs to be still to be insulative. So if we have convective loops moving within it, we're not getting the thermal performance. We're reducing that R value.
And next we have Raul asks, can Intello be in contact with J boxes?
Yeah, no concern there. The Intello doesn't have like a flammability concern or anything like that. Just make the space for it. So that is like here on the right, we're showing the strapping on the underside. That's just what we call a service cavity to create a chase for those outlets and things. But I oftentimes see folks using the Lesco box, which is our airtight outlet box. It's just a plastic box that you set your junction box or whatever it might be within it. Or you can make a little alcove by having the Intello follow some wood framing or visconing some wood joints. So make the space that you need, and it's fine if it's touching some of this electrical. But the electrical should have that, sheathing over the wire casing. It's not a raw hot wire touching it.
And next we have Nathan. Can you use Viscon along the top plates for air sealing for an attic insulation retrofit, removing the old insulation, then replacing new?
I'm sorry, can you repeat that for me, Johnny?
Sure. Can you use Viscon along the top plates for air sealing in an attic retrofit? This is a situation where they're removing old insulation and replacing it with new insulation.
Yeah, so let's call this a retrofit, and you're trying to access this top plate right here to air seal it for your exterior air barrier transition to come inwards. Yes, you can treat that with Viscon. Um, Viscon's probably very appropriate for that location in terms of just that limited access. It can be hard to get in with a piece of tape while you reaching in with a brush or using the aerobic sprayer does work well. In general, I prefer tapes because it's easier to play quality control regarding the install. With fluid applieds or using like the Contiga HF adhesive bead, it's just harder to know if you applied the proper thickness everywhere, if you got that little joint transition at the proper thickness. So, it just kind of takes a little bit more of a careful hand for installing.
And then lastly, we have Brad. I wonder how applied gable end overhangs work with respect to the applied rafter tails / vents. Those gable end overhangs would need to fasten perpendicular to the applied rafter tail vents, which would obstruct venting to the roof at those ends.
100%. It is a pain in the butt. And for the continuous ones, you're just taping around it. But where these bat ends would be sticking out to create that outrigger there, I'm seeing folks groove the underside of them just to allow some drainage right there. So devil's in the details. Yes, that will complicate things. That will interrupt some of the venting and drainage right there. I could say that the venting is now happening from that outside in a little bit to meet that, and then it can still be drying. But yes, that is a concern and maybe a reason to use hangers applied to the wall to create that overhang instead of these kind of sleepers that are used on top of the roof deck. So you could have hangers onto that wall that are just brought up to the proper height.
And with that, I think that was the last question we had. Just one more plug to download our smart enclosure details if you haven't already. Rachel dropped that link in the chat earlier. And we're going to follow up with a recording of all of this and the full list of links in your email. We'll follow up with all of that. And I really thank you all for joining us again. We're coming in right at 1 hour, so perfect timing. Thanks, Nick, for all of this very clear pictures and guidance on this. And we'll definitely be coming back next month with another in this series. It seems like these have been very well appreciated, and so we're definitely going to be continuing this detail series.
Thanks for joining, everyone. Thanks for taking the time.